Hi, my name is Arupa Chaji. Today I'd like to talk about artificial intelligence. About a year ago, I took part of a program at MIT, Chief Operating Officers Program, which is made up of two parts. The first part is fixed, a core program with weekly assignments, and the second part had two electives. And these two electives, you could choose what you wanted. And I chose something which I do nothing about. I chose artificial intelligence and I chose Internet of Things. Because I say to myself, like I say to everyone, if not now, then when, correct? So based on these two things, I'd like to talk to you about what I submitted for my project and I received exemplary assignment. So sit back, relax, let me explain. If you made a product A, B, C, D, E, and this product was made up of, say, 5 sub-assemblies, A, B, C, D, E. And let's say, for example, we had data from the field on what broke down, on the quality issues, and later on, we also had data of all the 5 assemblies. Each assembly has a test report released for the quality purposes. So sub-assembly A may have 10 or 15 or 20 different specifications which are measured. Assembly B the same, C, D, E all the same. Each one would have its own characteristics which was released for quality. Now, and then during the assembly process, imagine we had 10 steps. At the end of every step 1, 2, 3, I call it quality test. So we have maybe 10 quality test positions. And as each of these quality positions, QT 1, 2, 3, 4, 5 till 10, we also measure things. We can measure 10 variables, 20, 30 variables. It doesn't really matter. So now, we ask ourselves, when we do these tests till the end of the production line, before we ship the final product, the product is A, B, C, D, E, we do an end-of-line test. At this end-of-line test, we do again a whole series of tests. Again, we have data. We store the data in the file. Okay, what then? Next. We now have accumulated a matrix of data with A, B, C, D, E on one side, product number 1, 2, 3, 4, 5, and on the right, all the columns of all the data collected. It should look something like this. We have A, B, C, D, E, product 1, 2, 3, 4, 5, going all the way down. And from left to right in green are all the data before we ship something. All the sub-assembly data, all the variables, all the quality test data, QT1, QT2, QT10, till the end of line. And then we get data from the field. What went wrong? And those products, we want to take the measurements out. Measure them again and see what actually we can see. Now, we're going to use AI. So we're going to take a step back. We're going to build an AI model, train the model, which will then warn us in production itself on when to stop. And this means every sub-assembly gets AI tested before production itself. Now, what happens now? We get more and more information coming in from the field. We train the data even more, and automatically, without having to do anything, we get warned. Sub-assembly level, assembly level, end-of-line level. The quality gets bit by bit improving, getting better. So I'll ask you, start small, start with a small pilot, build the experience, giving you positive results, and maybe within a year, we need to start thinking about things we can't measure. People, weather, design changes along the way, wear and tear of machines in production. These will be the variation. But eventually, you'll have a trained model which will slowly converge. Expect within a year. Next week, I'm going to talk about my IoT submission, what I submitted for my Chief Operating Officers Program. So till then, I wish you, let's take small steps, continuously improve on quality, time, and cost. Yes, please tell me, how can I help you do something amazing? Thank you very much. God bless. Bye.